In this lesson, we're going to factor out the GCF from a polynomial. Let's begin by factoring the GCF from binomials. Now the steps are: determine the GCF of all the terms that are in the polynomial. Second, factor out the GCF and place the remaining terms in parentheses. So here we're given to factor the GCF out of 4x minus 20. So again, you can write them as products. 4x is 4 times x, and then for 20, that's 4 times 5. So I want to look to see what is it that they share in common, these two terms, and I can see here that they have a 4 in common. That is called the GCF. So the GCF is going to go on the outside, and whatever is left is going to go in parentheses. So parentheses x, bring your sign with it, minus 5, close parentheses. And you can always do the distributive property to check. 4 times x, yes, is 4x. 4 times negative 5, yes, it is negative 20. And there you have it, factoring the GCF from a binomial. Let's do some more practice factoring the GCF from binomials. So here we have 8y minus 24. And again, what you want to do is you want to be able to look inside those numbers and find what is the greatest numerical factor that they share in common. So I know that 8 times 3 is 24, and here's an 8 for the first term. So the GCF then is going to be an 8. Next, we want to put in parentheses behind it what is left once you take that 8 out. Well, once you take the 8 from the first term, you're left with just y. So y minus, always bring the sign with it. When you take the 8 out of the 24, you're going to be left with a 3. So then it's y minus 3. For the next example, we don't have any numerical factors, we just have variables. So we want to know in terms of y, how many y's do they both share in common. So recall that you always look at the variable that has the least power. So the first term has a power of 2, the second one has a power of 1. So this is the least power, the power of 1. So the GCF would be 1y, that's on the outside. And then what's left is going to go in parentheses. So when you take 1y out of the first term, so you know you have 2 y's. If you take 1 away, yes, you're going to have 1y left over. So that's going to be y, bring your sign with it, plus. If you take a y from the second term, you're not left with anything. So when you cancel the whole thing out, you have to replace it with a 1, not a 0. So put a 1 in its place. So in parentheses then, you're going to have y plus 1. Let's use the distributive property to check, just in case you're in doubt. Y times y, yes, it is y squared. Y times 1, you know that any number times 1 is that same number. And so that is how you would factor a problem like so. Let's go to example 3. We want to look inside 15 and also look inside 24 to see what is it that they share in common in terms of their numerical factor. Well, 3 times 5 is 15. 3 times 8 is 24. So they have a 3 in common. It also, in terms of their variables, we look at the smallest power of k, and that would be the power of 2. So that's going to be k squared has to be part of the GCF. So that would be 3k squared as my GCF. And whatever is left goes in parentheses. So when I take the 3 and 2 k's from the first term, that's going to leave you with a 5 for the numerical part and 1 k for the variable. So that's going to be 5k. Bring our sign with it, minus. Okay, let's take 3k squared out of that second term. When we take the 3 out for the numerical part, that would leave you with the 8. If you take 2 away, you don't have any more k's. So then in parentheses, you should have 5k minus 8. Now I want you to see if you can try to do the last one on your own. Pause the video for a moment. I want you to find the GCF, what will go on the outside, and then write what's left that goes in parentheses, and then I will check in just a moment. Okay, so what did you find to be the GCF of that? Well, if you said 3mn, then you are correct. And recall, what is left goes in parentheses behind it. So how did you do on that? I'm sure you did well. So let's move on to trinomials. In factoring the GCF from trinomials, it is pretty much the same as you did with binomials. You want to look at all your 3 terms in terms of the numerical part of it to see what is it that they all 3 share in common for the greatest number. And then for the variable, remember here it's just the q, so you want to look to where you see the q that has the least power or the smallest power, because that is your GCF. Now, one other way you can do it until you get the hang of it, you can go ahead and write them out completely as products. For example, 2 times 4, and then 3 q's for the first term, 4 times 5 with 2 q's for the second term, and 3 times 4 with 1 q for the third term. Now I want to look at all 3 terms to determine what is it that they all 3 share in common. And what we can see here is they all share a 4 and a q in common. So 4q then would be my GCF, which is going to go on the outside, and we can readily see what is left. What is left is what's not circled. So for example, you would have 2q squared, because you have 2 q's. So 2q squared minus 5q minus 3, close parentheses, and there you have it, factoring the GCF from a trinomial. In this example, we're asked to find the GCF of this trinomial. Notice we don't have any numerical factors here. We're only dealing with variables. Whenever you have a scenario where you have more than one variable, just simply perform them in ABC order, one at a time. So since V comes first, let's start with our V's. Recall, for the variables, you want to find the least power among all the V's. So that would be 1V, because notice that the second term only had 1V versus the others had 2. So 1V would be part of the GCF for the V's. Now let's focus on our W. We want to see out of all three terms which one has the smallest or least power, and that also is 1W, because on that last term it just has a power of 1. So my GCF then is going to be VW, and then whatever is left, once we're going to have to take 1V and 1W from each one of those three terms, and what we're left with, recall, goes in parentheses behind it. If you come across a scenario to where you're asked to factor out the GCF, but you notice that the first, or what we call the leading term, is a negative, then that means that you are going to factor out a negative, but you have to be careful and make sure you change the sign of the remaining terms that are inside the parentheses. So let's do an example to see what that looks like. So on the first example, notice that this trinomial, the leading term is negative 3x squared. Whenever it starts with a negative, you have to factor out a negative. I know that 1 times 3 is 3, 2 times 3 is 6, 3 times 11 is 33. So I want to know what is it in terms of a numeric number that they all three share in common, and that would be a 3. But because it starts with a negative, we're going to factor out a negative 3. And now what we're going to do is we're going to write what's left in parentheses, but we're not going to bring down the signs that you see here. Instead, you're going to bring down the very opposite. So inside the parentheses, after the first term, your next sign will be a negative and then a positive. It'll be the very opposite. So I'm going to go ahead and fill in what's left once you take a negative out. And notice here, as I stated, that the first sign would be a negative and not a positive. And the last sign, instead of a negative, it is now a positive. And it checks because let's do the distributive property. Negative 3 times x, negative 3 times x squared, it does equal negative 3x squared. Negative 3 times negative 2x, it does equal positive 6x, because a negative and a negative equals a positive. Negative 3 times positive 11, it does equal negative 33. So again, when it starts with a negative, factor out a negative, but make sure when you write the signs within the parentheses that they're the opposite of what you would see behind the original polynomial. Let's do one more example. So again, the fact that in this trinomial, the leading term is a negative, so I want to factor out a negative. I know that 2 times 10 is 2 times 5 is 10, and 1 times 5 is 5. 3 times 5 is 15, and what I heard in all three cases was a 5, so they all shared a 5 in common. And because it starts with a negative, I'm going to factor out a negative 5 as my GCF, along with an x and a y that all shared in common. And recall, we're going to write what's left in parentheses. So in parentheses, your next sign after the first term will be the opposite of this, so it will be a positive. The last sign in your parentheses will be the opposite of this, which is a negative. So rewrite what's left in parentheses. You can always do the distributive property to check, but again, just keep in mind if the leading term is a negative, then you must factor out a negative GCF. For these last two examples, I want you to pause the video and see if you can do them on your own. You're going to factor out the GCF, so the fact that both trinomials begin with a negative, the leading term is a negative. So that means that for both cases, make sure you factor out a negative GCF. Remember, GCF is something that they all share in common. And then write what's left in parentheses behind it. Okay, let's see how you did. So what did you say the GCF of the first example? If you said -2, that's correct. They did not all share an x in common. That's why you notice there's no x to be part of the GCF, because that last term did not have an x. The only thing that they all share in common is a -2. And then we're going to go ahead and write what's left in parentheses, and be careful with your signs. Make sure that your signs coincide with what they should be. Last example, I want you to go ahead and do that, and then tell me what is the GCF. Okay, so if you said the GCF is -6AC, then you are correct. And then you're going to write what's left in parentheses. So how did you do on those two? So hopefully you did fine. If you didn't understand it, please feel free to rewind the video and go back through it to make sure that you understand it, because it's going to be very important as we move on to the next concept.